This video will go over section 7.2 homework problems. The first one's number 11. An airplane flying into a headwind travels 1,700-mile flying distance between two cities in 3 hours. On the return flight, the airplane travels this distance in 2 hours and 30 minutes. Find the airspeed of the plane and the speed of the wind, assuming that both remain constant. So first, we're looking at two trips. We're looking at when we're going and when we're returning. On our way there, they talk about traveling into a headwind. So headwind means flying against the wind. And then we're going to use airspeed and speed. We can use A for airspeed and S for speed. And so for the airspeed, let's call that A. And if you're traveling against the wind, that means it's going to be harder. So we're going to subtract the speed of the wind. So I'll get A minus W. And on the return flight, we're going to be traveling with the wind. So that's going to make it plus. So the return is with the wind. And the going is against the wind. Okay, so now that we have this here, we also need to consider the distance formula. So D is equal to R times T. D stands for distance, R stands for rate, and T is the time. Okay, so what we can do here is the distance on the going trip was 1,770. And then the rate is going to be A minus W. And the time, it took us 3 hours. And then on this side, we have the distance is the same. And now the time is different. It's going to be 2 hours. And then for 30 minutes, we need to convert that to hours. So we can do that by writing it over 60, since there's 60 minutes in 1 hour. So this reduces to half. So 2 hours and 2.5 hours. So now let's simplify these equations a little bit further. So if I distribute the 3 in here, I get 3A minus 3W. And distribute the 2.5. Okay. So now let's look at this as a system of equations. My first equation. And then my second equation. If you don't want to work with decimals, then we can get rid of that decimal. So I'm going to write this as 1770 equals 3A minus 3W. And I'm going to multiply all of this by 10. So 10 times 1770 is 17,700. 10 times 2.5 is 25A. 10 times 2.5 is 25W. So again, you can leave it as a decimal, or you can get rid of the decimal by multiplying by 10. Now we need to cancel a variable. So let's cancel out the W's here. So in order to make coefficients the same, I'm going to multiply the top by 25. And then I'm going to multiply the bottom by 3. So 25 times 1770. Let's use the calculator. So 25 times 1770 is 44,000. $250. And then 25 times 3A is 75A. And 25 times negative 3 is negative 75W. And then 3 times 17,700. See, what do we get? 17,700 times 3 is 53,100. 53,100 is equal to 75A plus 75W. Let me just rewrite them down here. So the first one is this one. And then the second equation, 53,100 equals 75A plus 75W. Okay, so we can add the two equations. So we have 0, 5, 3, 7, 9. So 97,350. 75 plus 75 is 150. A. And then so negative 75 plus 75 is 0. We're going to divide by 150. So A is equal to 649. Okay, so now that we know A, we can use one of the previous equations to find W. So I'm going to use 1,770 is equal to 3A minus 3W. So I'm using this equation. And I'm going to substitute A, which was 649 minus 3W. So 649 times 3 is going to be 1,947 minus 3W. So we can subtract 1947 on both sides. So we get 1947 minus 1770. And 177 divided by negative 3. 15 divided by 3 is 15. And then we get a 27, so 9. Okay, so what does this mean? Since it's a word problem, we want to kind of write a sentence here. So we can say that the airspeed of the plane is 649 and the wind speed is 59. And we're looking at miles per hour since we were given the hours. 649 miles per hour. Miles per hour. So then that would be your second answer. So we would enter 649 and 59. So let's go on to the next question, number 12. Find the equilibrium point of the demand and supply of the equations. So they gave us two equations. We have P equals 530 minus 0.5x, and P is equal to 334 plus 0.2x. So notice here that we already know that P is equal to this and P is equal to this, so we can use substitution. So I'm going to take all of this and plug it in for my P over here. So I can solve for x. So I'm going to add 0.5x and subtract 334. So this would give me 0.7x. So here we would get 196. That's 0. Divided by 0.7. So x is equal to 196 divided by 0.7. 280. Now that we know x, we can plug it into one of the equations. So I'm going to use this second equation here. Substitute 280 for x. Multiply this. So times 0.2 is 56. So p is equal to, that's 10, 9, 390. So they want us to enter as a point. So x was 280 and p is 390. So the last problem I would like to work on is from section 7.1. I forgot to include it in my last video. So this is section 7.1, number 14. A small software development company invests $11,000 to produce a software package that will sell for $58.55. Each unit costs $7.45 to produce. How many units must the company sell to break even? And how many units must the company sell to make a profit of 90,000? So first of all, we want to look at what does it mean to have a cost and a revenue and a profit. Okay, so let's look at cost. So the cost is made up of the variable cost plus the fixed cost. So the variable cost is how much does each product cost to make. So we'll say cost per unit. And the fixed cost is just a fixed cost that you know you'll have every month or every year. So if we look at the problem here, a small software development company invests $11,000 to produce a software package that will sell for $58.55. Each unit costs $7.45 to produce. So we can write that the variable cost is $7.45 per unit. We don't know how many we're going to produce, so we can call it X. Plus the fixed cost was basically they invested $11,000, so our fixed cost would be $11,000. And now let's look at revenue. So the revenue is basically the selling price per unit. So how much you're selling the product for. So here they tell us that it will sell for 58.55. And we don't know how many, so we can call it X. And then the profit function is equal to the revenue. So basically how much money you bring in minus we have to subtract our costs. And that's going to tell you what your profit is. So to break even means that your profit is going to be 0. Okay, so this means break even. In other words, you don't make any money. Okay, so now notice here what I can do is I can bring my cost on this side. And so to break even just means that your cost is going to be the same as your revenue. And so we can use that information to help us solve this problem. So it says how many units must the cost sell to break even? So notice here that the cost is equal to the same as the revenue. So there's two ways to do this. The first way is just simply using this equation here. And then the second way is trying to set up a system. So I'm going to use this first way. So I'm going to write here first way. Okay, and I'll write C of x is equal to Rx. So my cost function is 745x plus 11,000 is equal to my revenue. And I'm going to solve for x. So I'm going to subtract 745x on both sides. So we get 11,000 is equal to 51.10x divided by 51.10. So x is going to be 11,000 divided by 51.10. And so we get 215.26. Okay, but what x represents here is the number of units that have to be produced. So these people are selling, let's see, a software package. And so it doesn't make sense to have 0.26 of a software package. So we're just going to round off to 215. Okay, so my first answer here would be we need 250 units to break even. And then it says how many units to sell to make a profit of 90,000. So I can use this equation here. So this is part 2 or part B. We know that the profit, I'm going to call it P of x, is equal to Rx minus C of x. So they're telling me to make a profit of 90,000. So I'm going to substitute 90,000 is equal to the revenue minus the cost for x. So we're distributing this out negative here. Okay, so let's add 11,000 on both sides. And we're going to subtract these. So we're going to end up with 58.55 minus 7.45 is 51.10. And if we add these, we get 0, 0, 0, 1, and 10. So 101,000 divided by 51.10. So x is equal to 101 divided by 51.10. And we get 1976.52. So again, we can have half of a software development, so we can round to 1977. So this would be 1977 units. Second way that you could have done this is a system. We have the cost is equal to 7.45 plus 11,000 And then the revenue was equal to 58.55. To break even is when your cost is equal to your revenue. Since we have Rx here, we can actually rewrite it. Instead of Rx, I can write it as C of X, since it's equal to each other. And so I can have two equations. And so you can get rid of the variables here. For example, if I want to get rid of the C of X, I can multiply all of this by a negative. So negative times this and negative times this. So this would become 0. And negative 58.55x plus 7.45x is going to be negative 51.10. That's 11,000. And so we get negative 11,000 is equal to negative 5110x divided by negative 1.10. So x is equal to 215.